In this session, we will see building HTTP requests for RESCONF, RESCONF HTTP responses. We're going to show two basic RESCONF requests, configuring RESCONF in a Catalyst 9000 lab, basic RESCONF tests using curl, using Postman, RESCONF error codes lab, and using Python. In order to work with RESCONF, we need a RESCONF server, a RESCONF client, and HTTPS as transport. Remember that HTTPS is divided in two layers, the security layer and the HTTP layer. We're going to talk about how RESCONF interacts with the HTTP layer. If we wanted to locate the RESCONF protocol within the OSI or TCP layer in model, we will place the secure transport or TLS here, and above that, the HTTP operations, and above that, the actual RESCONF XML or JSON Yang-based code. And above that, we have the clients. We may use curl, Postman, Python, or even Catalyst Center that uses a REST API to interact with RESCONF. RESCONF clients are going to create HTTP requests and will send them to RESCONF servers. RESCONF servers reply back with HTTP responses. We will see how to build HTTP requests first. The first three fields of the HTTP request form what is known as the start line. The start line follows this format. First field, the method. The available methods that a client may use depend on the server. Remember that methods are given in uppercase. The methods that a RESCONF server must make available to clients are post to create, get to read, put to replace, patch to update, and delete. This is why RESCONF qualifies as a CRUD tool. Bear in mind that put replaces large blocks of data. For instance, Yang list, patch replaces specific data fields, and post creates new data instances. Let's put some examples. If we wanted to replace completed interface data, we will use put. If we wanted to modify just the description of an interface, we will use patch. And if we wanted to create a new interface, we will use post. Be aware that there are other methods available out there. Their availability depends on the server. Next field, URI. URI stands for Universal Resource Indicators. A type of URI that we usually work with are Universal Resource Locators or URL. With RESCONF, we are going to work now with Uniform Resource Names or URNs, which are IETF resource IDs. These are separated by columns. A URI may include a path, parameters, query, and frag. For RESCONF, most of the time we are going to use only the path, but as our RESCONF queries become more complex, we may use parameters and queries. Bear in mind that in order to build these URIs, we have restricted, unsafe, reserved, and escape characters. For instance, if we were using a browser as HTTP client, only this part will become the URI. The RESCONF path route is usually /RESCONF. The RFC actually establishes that clients should discover this path dynamically using a get operation on this resource. However, for this session, we are just going to assume that it is always /RESCONF. Now, what lies directly below the root of the RESCONF API? Below the /RESCONF path, we have the data path, which is mandatory, the operations path, that is optional, and the Yang library version, which is a string leaf, that is mandatory. Within the data path, we will have access to configuration and state resources. This is where data stores live. Within the operations path, we will have access to some remote procedure calls. And inside the Yang library version leaf, we will find the IETF Yang library module date. Most of the time, we are going to follow the data path because that is where the configuration and state data are located. We are going to then follow that up with a URN that establishes a valid Yang module and a container. Examples of that is this for the native Yang model, this for the IETF Yang model, and this for the OpenConfig Yang model. From this point on, we can map Yang resources to a path by drilling down the Yang tree from top to bottom, adding elements to the path from left to right. If another Yang module has to be referenced, we can use the URN Yang module and container. Next field, HTTP version. We have several HTTP versions out there. Most of the time we will use HTTP version 1.1. Next, we have headers. We may include several headers within our HTTP request using this format. The first header that we are going to talk about is the host header. This header may be an IP address or a domain name. In our browser example, this part will be used in order to create the host header. The accept header. With the accept header, the client is asking the server to reply back with a specific type of content that in this case is going to be referenced using a MIME type and a MIME subtypes. These are examples of accept headers. So if you want to receive XML code back from the RESCONF server, you will need to use this header, and if you want to receive JSON code back from the RESCONF server, you will need to use this header. With the content type header, we are going to describe the contents of the body that we are going to send to the server. We are going to use a MIME type and a MIME subtype. These are examples. If the body that we are sending to the server contains JSON code, we are going to use this header, and if we are using XML for the code, we are going to use this header. Next, we have the authorization header that is going to authenticate ourselves to a RESCONF server. We may have the basic authorization header that includes a base64 encoded string with a user and password, and there are several examples. For instance, we can have the better authorization header that includes a token. As an example, in this online site, we can provide a username and a password, and we will receive the basic authorization header. Finally, we have the body field. With the body field, we can send Jam-based code to the server. It may be written in XML or JSON, or it may be missing altogether. Just a note here about how to design the body and the URI when we are using post. When using post, the URI will define the path to the resource, and the body will include only the necessary values in order to create this resource. Some things to remember about HTTP requests. HTTP methods always use uppercase, put replaces whole blocks of data, patch replaces specific pieces of data, post creates new instances of data, the basic authorization header includes the username and password. We are going to work with these MIME types and subtypes when working with XML or when working with JSON. These are going to be used when working with the accept and content type headers. Let's talk now about the HTTP response fields. First of all, we have the HTTP version. This is the highest version supported by the server. Next, we have the status code, which is only a number whose meaning depends on the range. We may have informational, successful, redirection, client error, and server error status codes. These are examples. Then we have the reason phrase. The reason phrase is a short phrase that summarizes what the status code means. So, for instance, for 200, the reason phrase is okay. For 404 is not found. Then we have the headers. For instance, the content type header will indicate what type of code is included within the body, either JSON or XML for RESCONF. There are several response headers, for instance, the title, age, public, retry after, warning, and so on. Finally, we have the body field, which includes the actual Jam-based XML or JSON response coming back from the server. Let's build our first RESCONF example. This will be the most basic request that we can create. We are going to query the top-level API resource, otherwise known as just the /resconf path. We're expecting this output, the data path, whether we have an operations path, and the contents of the Jam library version leaf. Now let's build our HTTP request. When we are performing a read operation, we are going to use the get method. Remember that methods are given in uppercase. When we are retrieving the top-level API resource, otherwise known as the root of RESCONF, we are going to include just /resconf as the URI. We're going to use version 1.1. For version 1.1, we must always include the host header. We're going to set it to the IP address of the RESCONF server. We want the server to respond to us in JSON format, and we are going to include the basic authorization header because we are providing a username and a password to authenticate ourselves to the server. We are not including a body because all the necessary information is included here in the URI. This is how the HTTP request will look like. We don't have to build this manually. That is why we are using an HTTP client that will create these requests based on user input. And this client that we are talking about is also going to be in charge of taking care of TLS. We cannot work with TLS manually. We need a software that must be in charge of speaking TLS with the server. Examples of these clients that we are talking about are curl, Postman, Python, and so on. Let's go for another example. We are going to change the hostname. Since we are changing existing data, we are going to use patch. Remember that the method is always given in uppercase, then we need to provide the URI that starts with the root of the API. Then we are going to go for data because that is where the configuration and state information live. We are providing a valid Django module and a container, and we are going to provide the version as 1.1. Now, regarding the header, since we are using HTTP version 1.1, we are going to include the host header that points to the IP address of the RESCONF server. Given we are sending a body written in JSON, we are going to use content type set to JSON, and we are going to use basic authorization, including a username and a password to authenticate ourselves to the RESCONF server. For the body, since it is written in JSON, we are going to start with an opening bracket and we are going to end it with a closing bracket. We are going to establish the value that we want to use to set our resource, and we need to provide the location for the resource within the Django tree. In this case, hostname exists directly under the native container. This is how the actual HTTP request will look like. We don't have to build this manually. The client that we're going to use is going to do that for us depending on our input, and it is going to talk TLS with the server in order to send this request. And this is the setup for our lab. We have a Catalyst 9000 here, and we have a client here connected in this local area network. In order to configure RESCONF, we are going to create a username. In this case, it is going to be RESCONF, privilege 15, password RESCONF, and the usual best practices AAA commands. Before configuring RESCONF, let's see what is the state of the processes that support RESCONF. In this case, Nginx is running because this is the HTTP server of Cisco. So let's see what happens if we disable the server. We will see that the Nginx appears now as not running. Let's enable only the secure server here, and now we will be able to see that the Nginx process is running. Now let's enable RESCONF with the command RESCONF, and we will see how the processes will start coming up. After enabling RESCONF, we can use show running config format RESCONF JSON. We will be able to see the configuration in JSON format using the native Django model. We can extract pieces of this configuration in order to build our programs. Now that we have RESCONF configured in the Catalyst 9000, we are going to test how it responds using some basic applications such as TELNET and the browser. Let's start testing our RESCONF server. Let's send some valid HTTP request codes. Let's TELNET to port 80 and see how it behaves. It is rejecting us because we're using normal plain HTTP without a TLS. We are receiving a 404 response, and we can see that the server is OpenResY. Let's try the same exercise for port 443 and see what happens. We receive a 400 baht request reply. The plain HTTP request was sent to the HTTPS port. So this is why we need a smarter client than TELNET, a client that can support and talk TLS with the server. Now let's use a browser as our RESCONF client. So we're going to type in this HTTPS because the browser can talk TLS, RESCONF, the username and the password, and the IP address of the RESCONF server, and we are retrieving whatever is in the top level API resource, which is /RESCONF. We are going to hit enter, and we are going to download this file. Let's see the contents of this file. Let's click on open with Notepad, and we will see the contents that we were looking for: the data path, the operations path, and the contents of the Django library version live. Let's see what else can we do with a browser. In this case, we are going to drill down through the data path, and we are going to provide the Cisco iOS XE native Django module and the native container. This points to the complete configuration of the device. So let's hit enter. It is downloading a file, and we are going to click on this, and let's see the contents of this download file. Open with Notepad, okay, and we can see the complete configuration in XML format. Now let's continue extracting data from RESCONF. In this case, we're going to drill down the Django tree, and we're going to go for the host name now. So let's issue hostname here, and we are going to hit enter. We are going to download another file. Let's see the contents. Open with Notepad, OK, and we will see the hostname. Continue testing the RESCONF server with our browser, now modifying the headers. In order to do so, we are going to install an extension that is known as mode header. So we are going to look for mode header. We are going to click here, and then we are going to install it. Then we are going to add to Chrome, and we are going to understand the risk and install anyway. With this test, we are going to retrieve the configuration again, but in JSON format. So we are going to use the mode header extension to help us with that. We are going to add a request header. In this case, it is going to be the accept header, and we are going to set it to Yang data JSON. So let's hit enter here. And we will see the configuration in Yang format. That's all about testing the RESCONF server with a normal browser. We are going to move on now and talk about curl. Now we are going to use curl. Curl is a really well-known application that is used among network administrators, database administrators, software developers, and so on, because it is easy to use client that will allow us to interact with many types of servers. In this case, we're going to use curl to talk with our RESCONF server. So we are going to, in this example, retrieve the top-level API resource for RESCONF, otherwise known as the root of RESCONF or just /RESCONF. So this will be the command. We are going to use -u to provide a username and a password, -X to provide an operation. Remember that methods are given in uppercase, and this will be the URI. We want to retrieve the top-level API resource, which is only /RESCONF. If I hit enter, I'm going to receive a warning regarding the certificate that exists within the RESCONF server. If we wanted to avoid or skip this warning, we will add a -K option. So in this case, we're retrieving the information that we were looking for, whatever exists under the RESCONF path, which is the data path, the operations path, and the contents of the Yang library version leaf. Okay, second example with RESCONF, we are going to extract the complete configuration of the device. So we are going to go for data, and then Cisco iOS XE native, which is the Yang module and the container. So we are going to retrieve the complete configuration in XML format. Okay, let's go for the third example of curl. In this case, we are going to retrieve the full configuration, but now we are going to retrieve it in JSON format. So we are going to add -H in order to add a header. We are going to add the accept header that will include the application Yang data JSON MIME and subtype. So we're going to retrieve the same configuration, but now in JSON format. Now let's do the fourth example. With curl, we are going to retrieve only the hostname. So we are going to type here the path for the hostname, and we are going to retrieve it in JSON format. For the next example, we are going to change the hostname. In order to do so, we need to start sending code to the server. So we need a JSON code in order to change the hostname. Since we do not know how to do that, we are going to do a little trick here. We are going to execute show running config format resconf JSON to see how the hostname is set with the running config. So we are going to copy that, and we are going to use that to feed our code. So hostname is set here. So we are going to save that in Notepad, and let's see where the hostname is located. If we look carefully, we'll see that it is located under this container. So we are going to save that as well, and in this way we have the code that we need in order to change the hostname. So we are going to feed this into a curl command. Okay, we are going to set the host name to something like hello from curl. This will be the body that we are going to send within our HTTP request. So let's start building our curl command line. We're going to start with the username and password, and then we're going to include this header content type set as JSON, because we're going to send JSON code to the server. We are going to use the method patch in this case, and we are going to set the URI to this value, for instance. And we are going to provide a body with the options -d. We are going to include this code, and we are going to close it and send it. So the change is done. In the next example, we are going to create loopbacks with curl. We need to provide the JSON code in order to create a loopback. Since we don't know how to do that, we are going to do the following trick. We are going to create a dummy loopback. Let's say loopback 10. We are going to provide a description and an IP address. Let's say this one. Then we are going to use this configuration as a baseline. We are going to execute short running config format RESCONF JSON, and we are going to look for the JSON code that defines a loopback. So we are going to save it inside a notepad, and we have to look this with care, because we need to know where the loopback interface lives. It lives inside the interface Yang list. So we are going to add that to our notes. And we also need to know where the interface Yang list lives. It lives directly under the container, which is this one. So we are going to add that to our notes. Notice that this character indicates that this is a list of loopbacks. We don't want to create many loopbacks. We only want to create one. So we are going to erase this character. We don't need that. So this is the necessary code that we need in order to feed curl with a body in order to create loopbacks. Now we can use this code as a baseline for what we want to do. So if we wanted to use, for instance, put or patch, we will use the following URI, and this will be our body. In this case, we are going to customize it. We are going to create a loopback 0, and this is going to be loopback created with patch. And we are going to use another IP address, in this case, let's say 10.1.1.1. And we have other options in order to create the loopback. For instance, we could create it with post. Remember that with post, when setting up the URI, we need to provide a complete path to the resource. So we need to include here interface. And the body will need to include only the value. So for post, the body will look like this. So it will be loopback created with post. This will be loopback 1, and this will be 2.2.2.2. So we're going to use this info in order to feed it to the curl commands in order to create loopback 0 and loopback 1. We are going to create loopback 0 with patch and loopback 1 with post. So let's create the curl command in order to create loopback 0 with patch. First of all, we are going to provide the username, password, and the content type will be set to JSON because we are sending JSON code to the server. Then we are going to use Linux capital X for the patch operation, and this will be our URI. And then we are going to provide the body. We are going to use this code for the body. It is somewhat large. We are going to close it. We are going to send it. Let's check the device and issue show interface description. Loopback 0 has been created. Loopback created with patch. Now let's create loopback 1 with a pause. So let's build our curl command line. We are going to provide the username, password, and the content type will be set to JSON because we're going to send JSON code to the server. Then we are going to provide the method. In this case, we're going to use post, and this will be our URI. Notice that we are including the full path to the resource, which is a slash interface, and then we are going to create the body -d, and we are going to copy the contents of this body. And then we're going to test and see interface description, and this loopback 1 has been created, loopback created with post. The next tool that we are going to talk about now is Postman. We are going to look for Postman download in Google, and we are going to click here and download Postman. From here, we have to click here on Windows, and then we need to provide an email address and then submit. We will receive the link to download Postman in our email. This is how Postman looks like. We have the collections area here where we can create collections and folders to organize our requests. We have the request area here where we can work with our request. We may select the method that we want to use to communicate with the RESCONF server. We can use get, post, patch, put, delete, and so on. This is the URL area where we can enter the IP address of the RESCONF server and the URI. We may select an authorization method. We have several at our disposal. For instance, the basic authorization will ask us for a username and a password. We have the headers option where we can add headers, for instance, the accept header, the content type header. We may enter XML or JSON code here in the body. We may execute our request with this button. We may save our request, providing it a name here, and clicking on this button. This request will get saved in a folder here, and this tab will acquire our request name. We can add more requests clicking on this button, adding more tabs. Finally, we have the response area where we will see the response coming back from the RESCONF server, the body, the response headers, and the status code. Let's create our collection. Let's say that this new collection is our Encor collection. And then within it, we are going to add a folder that is going to be basic RESCONF requests. Okay, let's go for our first example. In Postman, we are going to retrieve the top level API resource, otherwise known as just RESCONF. So we are going to add authorization here, basic RESCONF, and we're going to send it. That's it. We're going to save it, and we're going to go for the next example now. In this next exercise, we are going to retrieve the full configuration of the device. So we are going to click here in plus to create a new request. We're going to use get. This is the URL that includes this URI. Let's go for authorization, basic authorization, RESCONF. Let's click on send. We are retrieving the configuration here. We are going to save this request, and we'll go for the next example. For the next example, we are going to retrieve the configuration again, but in JSON format. So we are going to click on plus to create a new request. We are going to use get. This is the URL. Let's go for authorization, basic authorization, and now we are going to include a header. We are going to include the accept header because we want to receive this information in JSON format. Let's click on send, and we are going to receive now the configuration in JSON format. We are going to save this one and go for the next example. For the next example, we are going to retrieve the hostname. So we are going to click on plus to create a new request. We are going to use get with this URL. We are going to choose basic authorization again, and we need to set up the headers. In this case, we are going to use accept again with this value. Let's click on send, and this is the hostname. We are going to save this, and let's go for the next example. For the next example, we are going to change the hostname. It is currently Catalyst 9000, so let's go to Postman. Let's click on plus to create a new request. In this case, we are not going to use get, we are going to go for patch. This will be the URL, and then we are going to go for authorization, basic authorization. Within the headers, now we are going to use content type, and we are going to set it to this value because we are going to send JSON code to the server. In this case, we're going to go for body. Let's select row, and this will be the code. Let's send it. This is the result. Let's check on our device, and we have changed the hostname. Now for the next example, we are going to create a loopback. We already saw how to create the codes to create loopbacks back when we talked about curl. So we are going to use the same code here. So let's bring Postman. Let's click on plus. We are going to use now the post method. We are going to add the URI. Notice that the URI must be as specific as possible to locate the resource that we want to create. Then we are going to go for authorization, basic authorization, headers. We are going to add content type, and we are going to set it to Jank data JSON. And then for the body, we are going to create this loopback 3 loopback created by Postman with this IP address. So let's send it, and let's check on our device. Loopback 3 loopback created by Postman. So far, we have been executing requests that are successful. So let's see what are the codes that we have been receiving. For instance, with post 201 created, with patch 204 no content, and forget 200 OK. So let's see and let's examine in this exercise what happens when we are not executing a request successfully. So this is what we have so far. So let's see now what happens when errors happen. So in this case, for instance, we are restarting the server, and while restarting this RESCONF server, I just executed this again. And in this case, given the RESCONF server is not ready, it is replying back with a 502. The server working as a gateway got an invalid response. So let's add this one. So for let's say that we received a 502 bad gateway. This happened when the server is still coming up. So let's see if it's up now. So the server is now up, and it is now able to respond. So let's start breaking some things here. Let's say that we provide an invalid URI. So let's break this URI, and let's send it. 404 not found. So let's add this one. 404 not found. In this case, the URI is wrong. So let's fix this. Resconf. And now let's, for instance, try to break the authorization. Let's provide an invalid username. So let's send it. 401 unauthorized. So let's add this one. 401 unauthorized. Username is wrong. So I guess that will be the same if the password was wrong. Let's break the password, and let's send it. Unauthorized. So far so good. Now let's see what is going on if we for instance, send an incorrect header. So let's do a common mistake. Instead of using a plus here, let's put a minus, and let's execute it. 406 not acceptable. So and we are also receiving some detail within the body. So not acceptable, MIME type supported, and it is actually giving us what is the correct one. We should use a plus sign, not a minus sign. So let's add this one, for instance, to 406, not acceptable, when the MIME type is wrong. So we are receiving more information within the body. So let's see what happens if we send some invalid value within the body. Let's say that we send this incorrect field, or let's say that the JSON format is not correct. So let's delete this closing bracket. So let's send it, bad request. So, and we are going to get informed that a malformed message was received. So let's see, we have that 400 bad request, incorrect JSON code. That's it. Now we are done with Postman. We are going to move on and talk about how to interact with RESCONF using Python. The best way to work with Python is downloading an IDE that includes the Python interpreter. In this case, I'm going to work with Honey 5.0. Before moving on, we need to install a particular package to work with HTTP request that is known as request. So we are going to go to Tools, Manage Packages, and we are going to type in request, and we are going to click here, and we are going to install it. There it is. We are going to create the first RESCONF Python program. So we are going to click here on New, and this is the actual code. It consists only of 4 lines of code. First line of code, second line of code, third line of code, and fourth line of code. Remember that the first thing that we have to do with a Python program is including a comment that declares what is this script for. Now let's try to explain what these lines of code actually do. With the import request line of code, I am telling Python that I am going to use all the code that exists within this package. Then we are going to call this get function that lives within this request global object. So with this function, we are going to create an HTTP request with the get method. And the result of this function will be an object that represents the HTTP response coming back from the RESCONF server. In order for this function to work, we need to provide the URL. The URL includes the IP address of the RESCONF server and the URI. In this case, the URI is only /RESCONF. We need to authenticate ourselves, so we're going to use this object, HTTP basic authentication, that requires a username and a password. And in this case, we're not going to provide headers, and then we're going to print the response. So with this line of code, we're going to print the response code, and with the other line of code, we are going to print the response body. So let's run it. Let's click here and run. And we are going to see a warning first regarding the certificate of the RESCONF server. We are going to see the response code, and we are going to see the response body. Remember that we are querying the top level API resource, whatever exists inside the RESCONF path, which is the data path, the operations path, and the contents of the Yang library version. We are going to improve our program, including this code. This code is going to disable the warning. So let's execute it again, and then we are going to see that we are not being shown a warning anymore. Now, as a second example, let's retrieve all the configuration from the device using Python. Let's click on New. This is the same skeleton for our program. The only change that we need to do is establishing what is the path for the configuration. So we're going to go for the data path, because all the configuration and state data lives in the data path. So we are going to provide the Yang module. In this case is Cisco iOS XE native, container native. All the configuration lives here. So let's run it. And this is all the configuration in XML format. For the next example, we are going to retrieve the configuration, but now in JSON format. So we are going to copy this code. We are going to click on New. We are going to paste it, and let's update this. This program retrieves all the configuration in JSON format. So in order to do so, we are going to add a header that is the accept header. So we are going to add this code here. So I am including the accept header set to yang.json. So let's run it. And now we are going to see the configuration in JSON format. In this example, we are retrieving the hostname. The skeleton is almost the same. We are going to retrieve the hostname in JSON format. We are going to include hostname in the URL. And remember that the accept header is set to JSON. So let's run it. The hostname is Catalyst 9000. For the next example, we are going to change the hostname. It is currently Catalyst 9000. So we are going to use the same skeleton. We are going to click on New, and we are going to change this. This program changes the hostname. In this case, we are not going to use get. We are going to use batch. Let's fix this URI. And we need to provide a body within this HTTP request. So we are going to include this code for the body, and we are going to add it here. Finally, we need to change the headers, because we need to inform the RESCONF server that we are sending JSON code within the body. So we are going to change this header, and we are going to use content type set to application and data JSON. So let's run it, and let's check on our device. Hello from Python. For the next example, we are going to create a loopback. We are going to create loopback 0. In this case, we don't have loopbacks. So let's go to our IDE. We are going to use this skeleton. We're going to click on New, and we are going to change this. This program adds loopback 0. So in this case, we are going to use other code for the body that we have explained how this code works in the curl part of this session. So we're just going to use that code that we previously explained. So this is the code for loopback. We're going to create loopback 0, loopback created by Python. And we are going to use this IP address 10.1.1.1. And let's use now post. With post, we are going to inform where is the location of loopbacks. They live inside the interface Yang list. And the content type is JSON. And let's execute it. Let's check on our device. Loopback 0 has been created, loopback created by Python.